Hello, welcome to this basic class of the instruments and the components used in electrical and electronic sector. This is a multimeter, and this multimeter has the provision of measuring DC voltage, AC voltage, DC current, and some signal can also be drawn out of this. Temperature with a temperature sensor, of course, and a diode, and which also is the buzzer mode, and plus the resistance. That is why it is called a multimeter. Once we take it to the buzzer mode, we can use it for the continuity test. Continuity test is very frequently used by engineers for verifying the type which is necessary, like this. This is a continuity test where we put it in the continuity mode, and then when we touch these 2 points, the buzzer sounds. So that is what is the basic functioning of a multimeter, what we had seen, and we'll be using it very frequently. And word of caution here, it can measure only DC current. It can never measure AC current. Let it be remembered that all the cheap quality, this is a very economical or a cheap quality multimeter, it can only measure DC current in the 200 milliamperes range maximum here, or 10 amperes you have to change this switch to this position. You have to change this red pin to here to measure 10 amperes. Otherwise the red pin will be here, the black pin will be here for measuring any current from 200 milliamperes to 2000 microamperes. That is what is the multimeter. And if you would like to see certain costly multimeter, these are certain costly multimeters where the arrangement is same. We have same features, excepting that it has got some feature like testing a transistor, its gain. Gain means we have discussed about the gain in the transistor section, and this also has got a hold button. That means once you press it, you can hold that number for future reference even if you remove the connections. This is also has the same arrangement, only difference, this also can only measure DC current. But if you want to measure AC current, there is a device which is called tongue tester or a clamp tester. This is a clamp tester where this is typically used for AC current measurement. AC current measurement, you don't have to do any connection. This tongue opens once you press this, and in the process the wire can pass through this, and you can see the current reading on the digital one here. It also has the other provisions like voltage measurement, DC voltage measurement, and then AC current. Of course we have to measure it in this tongue only, that is the clamp only, and the resistance also, plus certain temperature arrangements also are there, and it also has AC voltage and DC voltage arrangement, and resistance measurement also. But mostly these things are used for the current measurement, and that too AC current measurement. Let it be very clear, clamp testers of this cheaper type do not measure DC current. They never measure DC current. So that is as far as the instruments are concerned, in the normal instruments that we use. Then we will go over to the standard, other standard instruments that we will be using in the projects or we might come across is a panel voltmeter. This is called a panel voltmeter, and panel voltmeters are normally AC voltmeters, and we can see them whenever AC voltage requirement is required. And then we come over to the other meters like an ammeter. This is an ammeter, panel ammeter, where it can measure current as far as the AC is concerned. The panel mostly we measure AC. That is why that the earlier one was a AC voltmeter. This is an AC ammeter. In early days we used to use analog multimeters. This is analog multimeter. These are presently not very much in use, but this gives a needle where the needle moves, and one has to, they are calibrated for AC, DC, for resistance, for ohms, everything. And this is now not much in use as far as the instrument is concerned. The next is an energy meter. An energy meter, there are some old generation energy meters where this is a digital energy meter. But if you recall, we had old generation energy meters also, where the energy meter used to be having a wheel, and that wheel is like this type. It has a wheel here, and then it has a meter. These are all analog types, but the present day it uses the digital ones, which has got digital reading, and it is based on the digital concept. It's not only based on the analog concept which used to be used earlier. This is also a voltmeter, a low cost voltmeter which is used in many instruments, and they are typically AC. Once you see this symbol, it is an AC voltmeter. Then we have certain protection devices that we use in the electrical system, is called the miniature circuit breaker. The miniature circuit breaker. This is a miniature circuit breaker. This miniature circuit breaker has always a current rating. This is rated for certain current, and once it exceeds that current, there is one connection here, one connection here, and when the current exceeds, this lever, the lever which is, when it is up, it is on, when it is down, it disconnects. So these are single miniature circuit breakers. They are used mostly in the AC. Then we also have three-phase circuit breakers. The three-phase circuit breakers are a combination of three in one unit, and that is a three-phase circuit breaker. They also are again current specific, that it has to be. We also have another type which is called a TPN, that is 3 plus 1. 1 is for the neutral, but it is advisable never to use TPN. TPN is for certain specific applications. It is always better to use the 3 type and not the 4 type. The 3 type means what we had seen is this one. We should use this one and not the 4 type. So this is what is the protection device, protection requirements for the AC supply. We have one more component which is also protection, is called MOV. It's called MOV, metal oxide varistor. These are used usually at the AC input side so that it suppresses any extra voltage, because these are normally rated at a particular voltage. After that voltage, this behaves like a short circuit, and in the process it doesn't allow any extra voltage to pass on to the equipment. For example, like this, we have a fuse here and we have a MOV here. Now the supply AC voltage is given here. Now if this voltage at this point exceeds its rating, yes. So what happens when there is any extra voltage appearing here? For example, we have this is rated at say 275 volts, and the supply voltage is till 230 volts. This behaves, this an ISO. This is not working. Now supposing between this the voltage exceeds more than 275 volts, this will immediately short circuit and the fuse will blow to protect the equipment. So that is what they are available in certain different types also. They look like this, and the other ones they look like this. So these are certain protection devices which are used in electrical circuits for protecting the equipment from extra voltage. Next we go over to the component which is called resistor. The resistor symbol is like this, and they are generally governed by, their value is generally governed by a color code, and the color code comes like this. This is a very well accepted color code concept. It starts with black, brown, red, orange, yellow, green, and so on. And we'll go over to this explanation here, where now this is a 3-band color code resistor. C band means this is one band, this is one band, this is another band, and this is the tolerance band. This tolerance band is not very important in terms of using for standard components, but the first digit is for the number 1, 2, 3, 4, 5, 6 like that based on the color. The second digit is also based on the number, whereas the third digit is the number of zeros. An understanding tip here. The understanding tip is that black, wherever the end is, we will always read from this side, not from this side. We read from this side, and when the last band is black, we have said the last band is only number of zeros, so it is 0. The first digit, now suppose you want to calculate the value of this. The first digit here looks like green, okay. The first digit is green. Second digit is a black, that means 0. So green is 5, 0, and the second digit, now the second digit suppose is orange. So this is a 50k. This is what is the way that we calculate the value. Orange is what we said, orange is 3 zeros, so it is 50k. Now an easy way to remember, whenever there is a last band is black, you ignore that. When the last band is brown, it is a resistance, sorry, this resistance is a 10 kilo ohm resistance. This resistance is a 10 kilo ohm resistance. Let's see how this is a 10 kilo ohm resistance. The first band is brown, is this. The second band is a 0, that is black, 10. And the third band is orange, so that is why 1, 0, 0, 0, 0. Orange means 0, 0, 0 or 10 kilo ohms. So this resistance is 10 kilo ohms. An easy way to remember is whenever the last band is black, you ignore that. When the last band is brown, it is 1, 0. When the last band is red, it is 2, 0. That means if the last band is 0, it is black, it is ignored. You have to only consider these two. That means 10 ohms, 20 ohms, 33 ohms, 47 ohms, like that, if the black is given. But if it is, so the last band when it is orange, it is in the terms of K, 10K, 22K, 33K, 47K, 1K, like that. When the last band is red, it is point some K, like 2.2K, 3.3K, 4.7K, 8.2K, like that. When the last band is yellow, it is 3-digit K, that is 100K, 200K, 330K, 220K, 470K. These are certain tips as per as the understanding the component, the register value. Since the value cannot be written on this, this is followed in this practice. Each value in electronic components have basically two parameters. Most important parameters are two parameters. As we see in the register, it has got the ohms to be indicated and the wattage also. The wattage means it is I square R, and we know once it's I square R, the wattage, the more the wattage, the surface area has to be bigger. In the process, it has to be a bigger size resistor. For example, this is a normal size of our say 1 watt resistor, or even the quarter watt will be half the size of this. Half watt will be half the size of it, and quarter watt will be 1/4 size of this. But when you look into certain higher wattage resistors, these are called higher wattage resistors, where they are typically wire wound resistor, and the value of that resistor is written in terms of its ohms and the wattage. So these are called high wattage resistors, and high wattage resistors are typically used in industrial application. This is also another high wattage resistor. They are all wire wound resistor, and the value is written here. So there is no difficulty in understanding or in finding out the value of this particular resistor. This is what is the identifying the resistors. Coming to capacitors, there are basically two types of capacitor. One is the electrolytic capacitor, where they are polarized in the sense one side will be positive and the other side is negative. Physical size, they look like this. There is a longer lead and there is a shorter lead. The longer lead is typically the positive and the shorter lead is the negative. They are also available in this size, where the positive negative is marked on the terminal itself so that they can be used accordingly. Coming back to another set of resistors, these are also wire wound resistors. They are high voltage wire wound resistors. They if there is a wiper in between or the moving arm in between, they are called rheostars. But these are not rheostars, these are high voltage resistors. So that is what is the resistor and capacitor. And as for the identifying the certain group of capacitors which is not electrolytic capacitor, for example, this is also a typical capacitor, where these are not polarized capacitors, these are non-polarized capacitors, and the non-polarized capacitors are mostly in the area of ceramic capacitors, polyester capacitor, and so on. Here what we look is the color coding is somewhat similar to resistor type, but then the numbering types are also very popularly followed. The numbering types like 105 stands for 1 microfarad or 1000 nanofarad, or 0.1 microfarad is 104, is 100 nanofarad, and 103 is for 0.01 microfarad or 10 nanofarad. And there are some ceramic polyester capacitors, they are in the color code, and the color code follows the same band as far as the resistor is concerned. Black is 0, brown is 1, red is 2, and this is read like this. That is what the polyester capacitors to be read in terms of their value to be noted. Their voltage rating is also the another parameter is the voltage rating. The voltage rating, if it is red, it is 250 volts. If it is yellow, if this band is yellow, it is 400 volts or above. And this band is the tolerance band, and tolerance band is not very important as far as this standard project work of ours is concerned. But then the other three bands are first band, second band, and third band. First band is number, second band is number, and third band is, when it is orange, it is 0.00 microfarad. When it is yellow, it is 0.0 microfarad. When it is green, it is 0.1 microfarad. In the sense that is being followed in that practice. So those were some passive components. We now come to the active components. Active components are, to start with the simplest one being the diode, or we call it rectifier or a diode. And rectifiers, the smallest size that we see here, a very popular one which is used is IN4007. It looks like this, and it has a rating of about 1 ampere at 1200 PIV, peak inverse voltage. And we know in electronics we have to derate their application in terms of the current and the voltage also. For example, if this is a 1200 volt PIV, we can use it maximum till about say 500-600 volts as far as the supply voltage is concerned, and a current rating of about 500 milliamperes to be on the safe side.